Hello! Okay, so the purpose of this video is to show you how to identify solutions to two equations by solving it algebraically. So this is basically similar problems that I've shown you in the other video, but instead I'll just show you the algebra behind it. Okay, so let's say I just start off, let's say I gave you something like y equals 2x minus 7, and the other one is 3x plus 4y equals 16. So just as a reminder, what we did in the previous class, we're solving this system of linear equations by substitution. So what we can do is we can take this 2x minus 7, plug it into here. So we get 3x plus 4 times 2x minus 7 equals 16. Distribute the 4. 3x plus 8x minus 28 equals 16. Combine like terms here, 3x plus 8x is 11x, so minus 28 equals 16. Add 28 to both sides here, so if I add 28, it looks like we're going to get 11x equals 44. Divide by 11. When you divide by 11, it cancels, get x is 4. Okay. Next, what I see what we can do is we can plug x back into any equation. I like the first one. The first one looks a little bit easier. Let's go ahead and do that. So y equals 2 times 4 minus 7, and then we get 8 minus 7, so that means y is 1. Okay, so our solution to this particular problem is going to be, oh, hold on, it's going to be 4 comma 1. So 4 comma 1 is going to be our solution to this particular example. We could always check it, right? So we can try plug it back in, make sure it works. So we have 1 equals 2 times 4 minus 7. 8 minus 7 is 1, so that works. If I try the other one, so 3 times 4 plus 4 times 1 equals 16. So 12 plus 4 is 16, and there we go. That just basically just checks to see that we have done it correctly. Okay. All right, so let's just show you a couple more examples that go along with this. So let's say I gave you another example. Okay, so let's say I gave you something like 4x plus y equals 6, and I give you 12x plus 3y equals 18. Okay, and our goal again is we want to try to solve the system of linear equations. So what I see we can do is we can actually try to use elimination. Let's say we use elimination for this one. So what I see is we can multiply this top equation by negative 3. If we multiply by negative 3, we can get rid of the positive 3y here, because opposite of positive 3y is negative 3y. So we're going to multiply top by negative 3. So negative 3 times 4x can be negative 12x. Negative 3 times y is going to be negative 3y. Negative 3 times 6 is going to be negative 18. Okay. Next, we're going to write out this next problem. So 12x plus 3y equals 18. Let's go ahead and add these equations together. So looks like the negative 12x and the positive 12x is going to cancel. Looks like the negative 3y and the positive 3y is going to cancel. And we get the negative 18 and the positive 18. Basically, they cancel. So we get 0 equals 0. So what this means is that anytime you get the same number on the left and the right hand side, so in this case we had a 0 on the left hand side, we get a 0 on the right hand side, we're going to reach this case and we have infinitely many solutions. So basically, as long as whatever x we plug in here and it fits with the y, so for example, let's say x is 1 and y is 2, so basically 4 times 1 is 4, and then 4 plus 2 is 6, so that works. If we try plugging 1 and 2 into here, 12 times 1 is 12, plus 3 times 2 is 6, so 12 plus 6 is 18, and that should work as well. So as long as it fits in the first equation, it should also fit in the second equation. And this would be an example where you'd have infinitely many solutions. And the reason why this happens is because this statement here, 0 equals 0, this here is always true. So this is always a true statement. So whenever you get a true statement, that's where you're gonna just get infinitely many solutions. Okay. Let's go ahead and just clear this and show another example. So y equals negative 4x plus 6, and I give you something like y equals negative 4x plus 10. Okay. So let's see what we can do here is let's say we want to solve the system. So like I showed you earlier, basically this y and this y, they both look the same. Okay, since they both look the same, what we can do is we can just take this expression and plug it into here. Okay, so what we have, if we were to write this out, this is negative 4x plus 6 equals negative 4x plus 10. Okay, and let's go ahead and try to solve for x. So basically we try to solve for x here. What we can do is if we add 4x to both sides, interesting thing that happens is this both cancels, and we're left with 6 equals 10. So try to think about it. Well, 6 equal 10? 6 does not equal 10. So anytime you get like a false statement, so anytime you get a false statement, this is here, so it's because 6 is not equal to 10, what we're going to have is this is a case where you're going to have no solution. So yeah, so you're gonna have no solutions to the problem because there's no way that we can solve for x. They basically just cancel each other out, and we got 6 is not equal to 10. Okay, so basically what this means is whenever you get a different number, you see this number here and this number here. Whenever you get a different number on the left and the right hand side, basically that will give you an example where you get no solutions. All right. Okay, I'm gonna stop the video right here. I'm going to continue really soon. Okay, bye. All right. Okay, so this is a completely different problem that we're looking at. So let's say you do something like this. So given f of x equals 4x minus 7 and g of x equals negative 5x plus 11, you want to set these two equations equal to each other and solve for x. So that's what this notation means here. So you see f of x here, we're substituting this here, and this g of x, we're substituting this here. Okay, so basically what we're going to do, I'm just going to go ahead and do that. So we have 4x minus 7, and we're setting that equal to, and then we're just setting it equal to negative 5x plus 11. Now, in order to solve for x, this is just a really easy exercise. So basically just what I see is we can add 5x both sides. Okay. So this cancels, we get 9x minus 7 equals 11. We can add 7 to both sides. Now here, now we get 9x equals 18. We can divide by 9, and we get x is 2. Okay, that's basically how you solve for x. So x is 2. If you wanted to, you could go ahead and plug x back into your original f of x and g of x, and basically that could give you that y coordinate. If you look at the other video, that basically shows you where the solution to this particular to the system of linear equations are, if you were to go ahead and graph both of these here. But if the question just says solve for x, basically we solve for x, so we're good. Okay, so let's say I gave you another example. So I'm going to go ahead and clear the screen. So again, same problem. Let's say I'm just going to just write it. So let's say I gave you something like f of x equals 2x plus 11, and I gave you g of x equals negative 11x minus 15. And then again, what I said, you want to set f of x equal to g of x and solve for x. Okay, so what we're going to do again is set these two equations, f of x and g of x, equal to each other, and you're solving for x. So we have 2x plus 11, and this equals this one, so negative 11x minus 15. Okay, now what we can do is we can go ahead and try to combine like terms. So what I see is we can add 11x to both sides here. Cancels, we get 13x plus 11 equals negative 15. We can subtract 11 on both sides here. So this cancels, and we get 13x equals, it's negative 15 minus 11 is going to be negative 26. Divide by 13 on both sides. 13 cancels out, and we get x equals negative 2. So now that we've solved for x, that's all we needed to do. So basically we get x is negative 2. Okay? All right, let's try to do another example. So let's say I gave you, let's say I would just, you know what, I'm just going to, okay, let's go ahead and just erase some of this here. And then I just change the problem up a little bit. So let's say I gave you, same problem, and I gave you something like this. So f of x equals 2x minus 3, and g of x equals 2x plus 6. Let's say I ask you to solve for x now. So same idea. We're just taking these expressions, so this, and we're taking this. Okay, so what we're doing is we're just going to set it equal to each other. So 2x minus 3. And then we're going to set that equal to, we're setting that equal to 2x plus 6. Okay, so now what we want to do is we want to try solve for x. So if we try to solve for x, let's try it. Let's see we add 3 to both sides here. Add 3 to both sides. This cancels. We get 2x equals 2x plus 9. Then we're going to go ahead and subtract 2x on both sides. Something interesting happens here. So this cancels and this cancels. So what left is we have 0 equals 9. So if you think about it, well, does 0 equal 9? Does 0 equal 9? No, it does not. Okay, so this again, like I mentioned earlier, this is a false statement. So since this is a false statement, this is not true. And this means that we have no solutions. No solutions. So in this case, basically, yeah, we can't solve for x. We can't solve for x. Haha. Yep. Yeah, that is an interesting case. Okay. So let's go ahead and do a few more examples here. Okay, gonna go ahead and clear the screen. Okay, so let's say I gave you something like this. So let's say I gave you something like f of x equals x squared, and g of x equals 4x minus 4. Okay, and let's say now instead like I showed you earlier in the previous video, right? F of x and g of x, they're basically just the same thing as y. You can just call it y. So let's just call it y equals x squared and y equals 4x minus 4. Let's say we wanted to actually solve for any solutions that we have for this. Okay, so what I see is, just like I showed you with substitution, right? Basically, we can take this x squared here. We can plug it into this y. So we get x squared. And then basically we can set it equal to 4x minus 4. Okay, now what we want to do is we want to try to rearrange the terms. So remember what we went over in unit 1? Remember we want something of the form ax squared plus bx plus c equals 0? So yeah, we can do some wonderful things with this. We could try to factor it if it's factorable, or we can try this quadratic formula. So let's try to see if we can just get it in that form. So if we want to get it in this form, x squared plus bx plus c equals 0, what I'm going to do is I'm going to subtract 4x and add 4. So if I subtract 4x here and add 4, what we have is this cancels, and what we are left with is we have x squared minus 4x plus 4. We have nothing on the right hand side, so that equals 0. All right, so let's look at this. Let's try to factor it. If we try to factor it, we can find two numbers that multiply to, so this is 1. So 1 times 4 is 4. And basically, what we can do now is we're looking at our b term, so negative 4 goes on the bottom. Let's think about it. Well, two numbers that multiply to 4 and add up to negative 4. Do that correctly, and that's negative 2. Negative 2 times negative 2 is positive 4. Negative 2 plus negative 2 is going to be negative 4. Divide by your a term, which is 1. So when we factor this, this is going to be x minus 2 times x minus 2 equals 0. Okay. In other words, what we can do now is we have two of the same term here. So this is just a coincidence. This won't happen all the time. So it just so happens what we can do with this is basically x minus 2 squared equals 0. Next, what I see what we can do is we can take the square root. So we can take the square root of both sides because we want to get rid of the square. So in order to get rid of the square, what we can do is we can take a square root. So the square root here. Square root cancel with the square. X minus 2 equals, so square root of 0 is a 0. So we're adding plus or minus 0. So basically, if we were to just write it, we have x minus 2 equals positive 0, or we have x minus 2 equals negative 0. It just so happens, well, negative 0 is the same thing as 0, right? So we have x minus 2 equals 0. In this case, we actually are just solving x minus 2 equals 0. So if we were to now go here, add 2 to both sides, basically this cancels, and we get x is 2. Okay, next what I see what we need to do is we need to go ahead and solve this. So we need to solve for y now. So now if we want to solve for y, what we can do is we can take one of the equations. I like the first one. The first one looks kind of nice. Let's take this first example here. So if I write that example here, basically what we have is this is going to be y equals, and we're going to take this x squared. So we're going to do 2 squared. So 2 times 2, or 2 squared, is going to be 4. So what this means is the solution to this particular example is going to be at 2, comma 4. 2, comma 4 is going to be our solution to this particular problem. Okay? That is it for this. Let me know if you have any questions. Okay, bye. Hello. All right, I'm just gonna show you 2 more problems. They're kind of lengthy, but it's okay. So what I'm gonna do is I'm just gonna go ahead and clear the screen here. Okay, and I'll just show you them. Okay, so this gave you something like this: y equals 2x squared, and then I gave you something like y equals x plus 6. So same idea. We want to try solve this system. This is called a linear quad system, if you want. So we have a quadratic, some sort of quadratic equation here, and we have a linear function here. So it's called a linear quad system. Okay, so let's try to go ahead and solve this. So basically, if we're trying to solve what we have here, we're going to take this 2x squared. I'm going to plug it into here. Okay, so we have 2x squared equals x plus 6. Again, what we want is we want something of the form ax squared plus bx plus c equals 0. So in order to do that, we can go ahead and rearrange the terms. We can subtract x and subtract 6. So we can subtract x and subtract 6 both sides. So this cancels. And what we get is we're going to get 2x squared minus x minus 6 equals 0. Now, a couple ways you could do this. I could see some of you be like, all right, well, I forgot how to do x method. So if I don't know how to do x method, I can do a is 2, b is -1, c is -6, and sing that lovely quadratic formula, x is equal to negative b plus or minus the square root of b squared minus 4ac, all over 2a. Or, if you guys remember how to do x method, we can use x method. So we can use, we can take this number, 2 times -6 is going to be -12. Then we're going to put the number on the bottom, so -1, right? So -1 goes on the bottom. So try to think about it. Let's try to figure out 2 numbers that multiply -12 and add to -1. I think that's -4 and 3. -4 times 3 is going to be -12. -4 plus 3 gets you -1. Divide by your a term, that's 2. We're going to reduce any fractions that we see. So this is -2 over 1. And then what we can do is we can rewrite this. So this is basically x minus 2, because of 1x, this is the coefficient goes in front of x, 1x minus 2. And then this one, so this coefficient goes in front of x, 2x plus 3 equals 0. Okay? Now, we want to find the zeros of this function. So in order to find the zeros of this function, we can take x minus 2 equals 0, and we take 2x plus 3 equals 0. Okay? Now what we want to do is we want to solve for x. So we can add 2 to both sides, we get x equals 2. So that's one of the solutions. We can subtract 3 both sides here. So we get 2x equals -3. Divide by 2. 2's cancel. And we get x equals -3/2. Okay? Now, this next part is where it gets a little bit interesting. Okay? So, what we have is we have 2 possible solutions for x. So now what we need to do is we need to go ahead and substitute it back into one of the equations we have here to try to solve for y. I like this one. You could do the other one if you want. It's totally fine. Let's try to use this one. So I'm going to use that. So basically, maybe it's a different color. Okay. Okay. So we're going to take this example. So we have when x is equal to 2. Okay. So when x is equal to 2, so what we can do is we're using this equation. So we're doing y equals 2 plus 6. So y is 8. So we have x is 2, y is 8. One of our solutions is at 2, comma 8. Okay? Similarly, we have another solution. We have it when x is equal to -3/2. So when x is equal to -3/2. Okay? So we can do this the same thing. We can use y equals, we're going to plug x. So this is -3/2. This gets plugged into here. So let's try that. So we have -3/2 plus 6. Now, of course, you could use calculator if you want, or if you don't feel like using calculator, what you could do is you could find a common denominator. So remember, if you guys don't remember how to find a common denominator, what we can do is we can change this 6 into 12 divided by 2, right? 12 divided by 2 is 6. Now that we have common denominators, we can add fractions. Hopefully you guys remember how to add fractions. So negative 3 plus 12 is going to be 9. So 9 divided by 2 is what we have. So what this means is that our solution that comes out of this is going to be at negative 3 comma 2 and 9 comma 2. If you look back at the video, the other video where I graphed it just by using decimals, this is negative 1.5 comma negative 4.5, and as you can see, that is exactly what we got when we graphed it. This is how you would do it if you had to do it algebraically. Okay, I'm going to show you another example. I'm going to go ahead and clear the screen. Okay, let's say I gave you something like this. So this is the circle one, x squared plus y squared equals 10. And I gave you the other equation was y equals 3x. Okay, and our goal now is to solve this system of equations. Okay, so what I see what we can do with this is we can take this 3x. So this 3x can be substituted into here for this y. So we have x squared plus, and then we can put 3x squared, right? 3x squared equals 10. So we're just plugging y into here. If you guys don't remember how to do 3x squared, that's basically 3x times 3x. 3x times 3x, so 3 times 3 is 9. X times x is x squared. So what we have is this is going to be x squared plus 9x squared equals 10. If you see here, these are like terms, our x squared and our 9x squared term. We're going to combine them together, so this is going to be 10. X squared equals 10. Okay, now what we can do is we can divide both sides by 10. Divide both sides by 10, cancels. We get x squared equals 1. Now, to get rid of the square, we have a square here. We need to take a square root to get rid of the square. Square root cancel with the square. So we have x equals square root of 1 is plus or minus 1. So that's where this lovely thing comes into play. So we have x equals negative 1 or x equals 1. All right. So now what we want to do is we have two possible x's. We have two possible x's right here. So guess what we have to do? We have to go ahead and find our y values for this. Isn't that awesome? So now, so we have when x equals negative 1. Let's choose one of these equations. I like this one. I think this one looks easy. Nice and easy, right? So what we can do is we can put, when x is negative 1 here, so we can have y equals, so 3 times negative 1. So this means y is going to be negative 3. So basically, when x is negative 1, y is negative 3. And basically, our coordinates is going to be negative 1, comma, negative 3. That's going to be one of our solutions. Okay, let's go ahead and create another. All right, so we did it where x is negative 1. We also need to consider the case when x is equal to 1. Okay, so when x is equal to 1, we need to use one of these equations. Let's go ahead and use this one. I like this one. So y equals, and then 3 times 1. So what we get is 3 times 1 is 3. So y is 3. So our other coordinates where they intersect is going to be at 1, comma 3. So that is basically it. So of course what I want you to do is you could go ahead and look at this video and see how it compares to the graphing video. Yeah? Isn't it cool seeing all these little concepts come together? Yeah, you guys thought you could probably forget some of this stuff. Oh, nope. Nope. Yeah, gotta remember it. All right, let me know if you have any questions, and I'll see you later. Okay, bye.